Hi, welcome to this video. Today I want to talk to you about this plane, this little plane that I designed. I want to talk to you about why I designed it this way, what are the techniques that I used, and so let's get into it. What I wanted to build. I wanted to build something cheap, easy and fast to repair and build, easy to tune and crash resistant. So something that is for the beginner modeler, but also for someone that just wants to fly, doesn't want a really complicated model or good looking model, scale model, but just wants to put something in the air and have a great time. So the design principles that came out of these necessities are that it had to be made with least amount of components as possible, with common available components. It had to be a small model, so as to be really crash resistant because it's light and the energy and impact is reduced. It had to have the minimum control surfaces possible, so only 2 control surfaces. And also low wing loading to fly it very slow and to be easy to spot in the sky. And it had to be made out of Corflute instead of maybe like materials like foam or 2D printed planes that are less resistant, and also foam is not waterproof. Instead, Corflute is a very tough material and it is waterproof. And there is also a really nice feature of Corflute that I will get into in a moment. And all these constraints came down to a simple delta wing design under 250 grams. Now this model that I have here, that is built with the common components. These are 20 gram standard receiver, 30 amp ESC when I only needed 50 amp ESC. So it's quite cheap and easy to find components. This comes down with the battery, 450 milliampere 3S, to 180 grams in total weight, so quite a lightweight model. You can see that, as I said, it has only 2 control surfaces with 2 small servos. These are carbon rods with steel that goes into the servo arm. To add rigidity, I put the carbon rods, and I've also put some carbon in the front here to protect the propeller in case of a rough landing. So it's the propeller is protected from all the angles, and the carbon absorbs all the energy of the impact. The nice thing I wanted to tell you about with Corflute is that you have these little canals in Corflute where you can slide in carbon rods of the correct size. For example, here I have a 2.5 millimeter Corflute, and I slide in 2.5 millimeter carbon to make it very, very rigid. You can see it doesn't want to bend much. I've put a couple, one here and one here, one in the middle, one small in the front, and also I have those taped down so I can remove them easily. And also I've put down a thin Corflute strip here, and I put in 2 carbon rods to give it longitudinal strength. So it's very strong in all the axes, very resilient. This has been through quite some crashes, and it still looks pristine, I would say, like new, like brand new. And one other thing that I am kind of proud of in my design is this strip in the middle, where you can mount all your electronics easily with the zip ties. You just slide in that zip tie in the canals of the Corflute, and you put your electronics and you tighten them, and you have a very modular design, so you can shift the electronics backwards and forwards to get the CG just right. So here we come back to easy to tune, and also light model and fewer parts, because you don't have to add weight in the nose or in the back to get the CG right for perfect flying characteristics, but you can just slide your electronics backwards and forwards on the rail. Yes, I think that's it. I have 3D printed small pieces here to mount the fin, the rear fin, also the servo arms. These small pieces are all 3D printed, and also the motor mount here. And you can put this together in about 1 hour, half an hour, and so you can just build one and get in the air pretty fast and have fun, just have fun.